Two-way frequency tables are a form that you will see some percentages or some probabilities that are given to you, but they're not in word form. It's just a different format that you'll see that information. So just kind of breaking down the pieces of the frequency table. First, you have the columns up at the top, and they will represent individual events. You'll also have some rows listed on the side, and they will be individual events as well. Okay, next you're going to have your cells that are beneath the columns and beside the rows. So for example, the upper left-hand cell would represent the number or percentage that falls within column 1 and row 1. And then that is going to continue. It's just like reading any table that you'd be given. So wherever that cell is, you can line it up to the column and the row that it goes to. Next, we have our totals. So your total for column 1 is going to be listed at the bottom of column 1, and that is going to continue across the table. So your totals for each column are at the bottom of each column, and the totals for each row are at the end of each row. Next, we have the overall total, and the overall total is the sum of all of the columns and the sum of all of the rows. So you'll only have one number in that overall total box. Right, that's just kind of breaking it down. Let's do some examples and it will come together a little more clearly. Example 1, the table below shows a survey of 100 authors by a publishing company. So there are 100 authors, that's our total. And it's broken into different categories or to different events. So you have the event that the author is new, so it's a new author, or they are an established author, but you can't be both necessarily. So you're either brand new or you've been there for a while. You can't have both at the same time. So it's got to be one or the other. Then you have successful or unsuccessful. And in this case, those cannot happen at the same time. You're either one or the other. Right, and now we're going to look at our first question and just kind of break down and see what do we have. So find the probability that an author is established given that she is successful. Okay, let's write this a little bit differently. So the probability that she is established given that she is successful. Okay, so remember, that's the probability of established and successful divided by just the probability of being successful. Okay, let's see what the table tells us. The probability that she is established and successful. So we have established and successful is 25 authors out of 100. And the probability that that an author is successful, well, how many total successful authors were there? So if I look at the successful column, there's 5 and 25, making a total of 30. So the probability of being successful is 30 out of the total 100. All right, so if we were going to find this percentage, you could simply take this and plug it into your calculator. Just be careful with your parentheses. So I'm going to put parentheses around the first fraction. We had 25 out of 100 on top. Whoops. And then we were dividing that by, I'll put another set of parentheses, 30 out of 100. Okay, so that's 0.83 repeating. So 0.8333 is 83%, roughly, 83.3. Or we'll just round it to a whole number. Okay, now let's find the probability that an author is successful given that he is established. Okay, I'm going to erase the 25. All right, so the probability that he is successful given that he is established. Okay, so again, it's the probability of both. I'm just going to shorthand and write both. Divided by the probability that he is established. Okay, so the probability of successful and established, again, is 25. So 25 out of the total 100 are established and successful. The total number of authors who were only established, so if they're established, 25 were successful, 55 were unsuccessful, making for a total of 80 that were established. Okay, so again, we can put this into a calculator. So we have parentheses, the first fraction, so 25 out of 100, divided by, and then a second set of parentheses, 80 out of 100. So that's 0.3125, or 31.2%. We'll just round it to 31%. Okay, let's do another example. Okay, suppose that past records in a large city produce the following data on a driver being in an accident on a day when there was record-breaking rain levels in Seattle. So first, let's look at our independent events. So we have event A is having an accident. Our event B would be having no accident. So you're either one or the other. You either have an accident or you don't. Then we have the event that it rains or that it doesn't rain. You can't have both. Again, our total is 1 or 100% of the time. So 100% of the time you're either in an accident or you're not. 100% of the time it's either raining or it's not. So let's find the probability of an accident, rain or no rain. So the probability of an accident altogether, regardless of whether or not it's raining. So if we're looking at the accidents and we look down at the total for accidents, rain or no rain, so we would add those together, 0.025 plus 0.015 is a total of 0.40. So the probability of an accident is 0.40, 0.040, or 4%. Okay, let's look at the next one. Find the probability of rain, accident or no accident. So what's the probability that it rains regardless of whether an accident has happened or not? So if we look at rain, we have 0.025, 0.335, which makes for a total of 0.360. So the probability of rain is 0.36 or 36%. Okay, next, find the probability of an accident and rain. That's really already given to us in this situation because we're already given that decimal number. It's 0.025. It's already right there for us in the table. So the probability of accident and rain is 0.025 or 2.5%. All right, finally, find the probability of an accident given rain. So this one is a conditional one. So out of the probability that it's raining, how often will there also be an accident? Okay, so first we have to find the probability of both. So I'll make a note of that. And we're going to take that out of just the probability that it's raining. Okay, so the probability of both an accident and rain was 0.025. That's what we just found. And then the probability that it's raining was 0.360. So we can plug that into our calculator and see what we get. All right, so that's 0.0694 repeating. So that's 6.94%. So this isn't really anything different from what we did before. It's just the information is shown to you in a different way, and it's important to know how to read that information. But that's all there is to two-way frequency tables. They're always either set up with the decimals like this, where in this case, the decimals are the percentages. And in the previous one, there were no decimals here. These were whole numbers.